Hello everyone, welcome back to my channel. Today we are going to learn the very basic thing in chemistry, that is about atoms, how the electrons are arranged in an atom. So our goal or our learning objective for this chapter are, first of all, we are going to discuss the particles in atom and very specifically the atomic radius, what is atomic radius and how electrons are present in the atom. Then we'll discuss isotopes, electron energy levels, and atomic orbitals. And then in the we're going to discuss the ionization energy. So we are going to start with the particles in the atom and atomic radius. So this video is particularly about the very first topic. Let's start with an atom. What is an atom? Atom is basically a word that is derived from a word atomus, which means indivisible. So earlier the scientists saying that it is indivisible, but it's not indivisible, and we learn it now. We have so many subatomic particles which we use in our daily life. So this was an old concept, and this word basically means this, but the definition is incorrect. So who named it? Democritus named it, and the John Dalton, he gave a concept of how atoms observe or they follow the law of conservation of matter. Moreover, atom was thought to be dense, spherical, and smallest. While the modern theory suggests that it has three basic subatomic particles. Very first one is the proton, second one is the neutron, and the third one is electron. Atom is very simple. It's just like our planetary system. So first of all, we'll talk about the nucleus. In the very second, there is a nucleus. In nucleus, we have two main subatomic particles, that are proton and neutrons. So overall, we say that the nucleus is the main thing of an atom that hold most of the mass, while the outer shells, which are, you can say, the orbits of our planetary system, so that is in those orbits electrons are present. So they revolve around the nucleus. So when we talk about the protons and neutrons, let's talk about their charge. Protons carry positive charge while there is no charge on the neutron. So if we say what is the charge on nucleus, then collectively we can say that nucleus is positively charged. Why? Because it contains the positively charged protons and the particles with no charge. So overall, if we sum it up, it would be plus one. So nucleus is positively charged, while the electrons, they are negatively charged. So overall, if we talk about an atom which contain both the nucleus and the orbits, so an atom is a neutral one because it has protons and electrons which are equal in number. So if we talk about their mass, if we compare the mass, this is not the actual mass. When we talk about the relative mass, it means we are comparing it with each other, like proton, neutrons, and electrons. We are not giving the actual mass of a thing. For example, if we talk about the atomic mass, or the, you can say, the mass number, so that give us the picture of the relative atomic mass, not the actual one. So we consider relative, we are comparing it with something else. So here, if we consider proton and neutron as one, then electron is much smaller as compared to these two, and it is almost 1836 times lighter than both protons and neutron. So this is the overall review of what type of structure an atom holds. So this is basically the modern structure, in which we say that in the very center we have protons, we have neutrons, but outer one contains electrons. These one are electrons. So if you look closely at this structure, you can clearly see that the atoms, they are not present in a like spherical pathway, but they follow a certain pathway, and we find these electron in those specific areas. So atom is very small. It has a size of almost 0.01 nanometer, An ordinary microscope can only show particles near to this. So if we talk about the modern theory, it is not smallest. It contains the subatomic particles that are electron, protons, and neutrons. Oh, here we have a little mistake. Let's correct it. And J. Berzelius was the one who determined the atomic masses of an element. So, if we want to observe the electrons, we need to use the electron microscope, because the ordinary microscope, or you can say the light microscope, is not able to magnify the object to that much extent. The electrons are very, very, very small. If we want to look at the structure of an atom, we need to use a very high tech microscope. So this is basically a diagram of graphite, where the white spots are the atoms that are arranged in the layer form. You might have studied this in IGCSE or O levels, where you have studied that the graphite are arranged in the layer form, and that's why they are quite soft. They can be like, oh, they can be molded into different shapes. So atomic size is about zero point 0.2 nanometer. The weight of atom is around 10 raised to power minus 27 to 10 raised to power minus 25 kg. So this is all about atom, that how atom looks like. But what atom cannot exist alone, because of its electronic shells that we are going to discuss in another video. So atoms need to have a complete atomic shell. So here, when we observe the atoms, most of them do not have a complete electronic shell or atomic shell, and we will discuss it later in the video, that how, what is meant by this. So uh, let's say they are not complete. They want a balanced electronic configuration or electronic configuration that helps them to become stable. So in order to do this, they make bonds, and the two atoms, or the more number of atoms that are connected together, they make a molecule. So a molecule is basically a smallest particle of a pure substance which can exist independently. So there are two type of molecules. One are the micromolecules, or you can say micromolecule. Other one are the like atomicity, if it has one atom, two atom, three atom, or four atom. So if we talk about the monoatomic one, you all are well familiar with these one. For example, helium, neon, xenon. These all are the noble gases which have a complete outermost shell. You might have studied it, so it's not that much difficult. Diatomic one, which contain two atoms like O2, H2, carbon monoxide. Triatomic like CO3, CO2, sorry, ozone, O3. And polyatomic mean many, like for example carbohydrate. Take an example of sugar, C6H12O6, or a polymer. So those are like how many atoms are present. So the other one is, if you look at water, water is what? Water is triatomic, because it has two hydrogen and one oxygen. So there are three atoms that are triatomic. But if we look at this oxygen, it has only two atoms. It is diatomic. Now let's talk about their size. As I mentioned earlier, they are like very small molecules, and they can be bigger molecules like polymers. As we discussed earlier, the graphite. Graphite is a very huge one molecule. It's a macromolecule. So there are two type of molecules: micromolecules and macromolecules. If we look at these, water and oxygen, these are very small molecules. So these are basically the micromolecules. But if we want to have a look at macromolecules, there's so many examples. Your whole body is a macromolecule. You have lots of polymers, you have proteins, you have DNA. These all are the macromolecules. The carbohydrates, the lipids, these are very big, big, big molecules. uh, Polymers we use in our daily life, these all are the macromolecules. Now the next thing is the atomic radius. What is atomic radius? So when we talk about like what is the size of an atom, so you cannot say, okay, this is the size of atom, or this is the size of atom. So it is different. So let's talk about atomic radius. What is atomic radius? So you know that atom is quite a small entity. You just cannot take its you cannot just measure its size like it's this much nanometer, this much nanometer. Why? Because the electrons around that are around the nucleus, they are constantly moving. You cannot just have their specific position. You might know about the Heisenberg's uncertainty principle. You might have learned that. If not, we are going to discuss this later. You may find it in another videos. So atom, because atom is constantly moving around the nucleus in a certain pathway, so we just cannot have an idea, okay, this is the size of an atom and this is the size of atom. We have to take some other way. We need some other method to determine the size of an atom. So when we talk about the atomic radius, why we need to take it? Because we have to take a size of an atom. You might observe it later, like these actually affect the properties of an atom. So the size of an atom is represented in the form of like atomic radius, covalent radii, or the ionic radii. So whether they are covalently bonding, ionic bonding, or what. So when we talk about size of an atom, so atomic radius, it is the average distance between the two nuclei nuclei. So, and we usually take it like this when we take a distance between a nucleus and the outermost shell. But here is a twist. What is that twist? We have to take the distance between the two nuclei of the same type of atoms that are covalently bonded. Why? If I talk about, like, for example, if it is H and it's Cl, so the radius is different for both. So I just cannot take the you can say the average of these distances. It will affect my result. Hydrogen is quite smaller in size. It has only one shell, while chlorine has three shells. So how can I do this? It's not possible. So we have to take a same type of, for a same type of atom. If one atom is hydrogen, the other should be hydrogen, so that I can take, or we can take, the average of that molecules. So non-metals are usually small in size, and we will learn it later why. It's like a reason. You might know the reason, but let's discuss it later. And we usually do it by the X-ray or by the spectroscopic measurements. So why radius is the one we are taking? Why we are not taking the diameter? Why we are only focusing on the radius? Because there is no sharp boundary. As we have discussed earlier, the electron is constantly moving in different directions in a certain pathway. So the position is not fixed. So the probability of finding the electron never become exactly zero, even at large distances. You just cannot like find it. So that's why we have to take a distance between two atoms. So these are the same atoms, and we just have to take the distance between these, and then we have to divide it. We have to take the average. The electronic probability distribution is affected by neighboring atoms. For this reason, the size of atom may change from one compound to another. For example, if it's F2, so fluorine is the highest electronegative atom, and hydrogen is different. So we have to consider the cases as well. Now, what if we look at the period and the group in the periodic table, how they differ? If we talk about the periods moving from left to right, what is the general trend? So the general trend that usually is that atomic radii decreases. Why? Now we are going to discuss the reason. So you have to pay the attention. So atomic radii trend is, for example, if we talk about the lithium has an atomic radii of 152, while oxygen has an atomic radii of 72. This fluorine has 73, fluorine has 72. Why is this? Why we are following same trend? They have same number of shells. So it's a period number 2. So they all have two atomic shell or atomic orbitals. So why the trend, like why the size is decreasing? Now if we look at the atomic number, or you can say the number of protons and the number of electron, it is 3, it's 4, 5, 6, 7, 8, it's 9. Let's just discuss the extremes, the left one and the right one. Now if you observe that there are 3 electrons in lithium while there are 9 electrons in fluorine, so what do you suggest from this? The the electronic charge is very high in fluorine as compared to lithium. Now, if the electronic charge is very high, it means there is much attraction between the particles of fluorine, as, or you can say particles, or you can say nucleus and outermost electron. The attraction is much higher as compared to lithium. So what is the first reason? The nuclear charge. Here we have 9 electrons and 9 protons. Here we have 3 electrons and 3 protons. So definitely here the nuclear charge is very high. There is a strong force of attraction. There is a very high pull. So when they attract each other, the size reduces. That's why lithium has a bigger size as compared to the fluorine. Moreover, the shielding effect is not affecting, because if it's the first shell, all of their first shell contains 2 electrons. There is no other shell. If we talk about period number 3, so there are 2 electrons in group number, sorry, atomic orbital number 1, orbit number 1, orbit number 2, there would be 8, and in third one respectively. So the inner electrons, or the shielding effect is actually caused by the inner electrons, is not affecting it at all. Now let's move to the electron shell theory, how we are going to like prove it according to this, because you have to give the reasoning in the question. You need to know the reason. You should know the actual words what you are going to use. First of all, the nuclear charge. This is the most important word that you need to mention if a question is related to atomic or radii. You just need to know that there is more nuclear charge. Okay, so atomic radius decreases when we move across a period from left to right, because there is increase in nuclear charge, there is increased positive nuclear charge, but at the same time the extra electrons are added to the same principal quantum shell, that is mean the same shell. So the larger the nuclear charge, the greater the pull. That's why the size reduces. So you should give the exact reason to the examiners so that your answer is complete. So this results in smaller electrons. Let's talk about down the shell. All of you know that the group number, when we move from the up till down, top till bottom, the number of shell increases. So automatically when there is an extra shell or extra orbit, it means the size is more. So atomic radii increases from top to bottom in a group. It's a general trend. What can be the reason? We have discussed this. Discussed it already, that the number of shell increases. That's why the size increases. Now, if we want to give an explanation, if a question is related to what is the general trend in this one, so we can say that the electron in why it's increased, because the number of shell are increasing. Number 2, the shielding effect, because there is one extra shell every time, so definitely the number of inner electron increases, it means the shielding effect increases. So when the shielding effect increases, the attraction between the nucleus and the outermost electron decreases. It means the distance increases, so the size becomes bigger. Now the ionic radii. How do we define ionic radii? Simple. The ions. This what is positive ions and what are the negative ions. So how does a positive ion form? When an electron is lost. So sodium is in group number 1. It has only one outer electron. It donates that to someone else in order to have a complete outermost shell. Now the inner shell would be complete. It's an ideal situation for this sodium. So positive ions are smaller than their neutral atom because the outer shell is lost. Now when the shell is gone, when an extra you can say extra jacket has been taken off, it means the size reduces. So the negative ions are generally larger. Why? Because we are adding in extra electron. When we add in electron, the electrons that are already present are not going to accept it easily. So there is some type of repulsion, and that repulsion actually increases the size. So, what are the general trends? Similar are the general trends that if we talk about a period, the ionic radii basically decreases, and sorry, here if it becomes it actually converts from electropositive to electronegative. Now the ions. So as we discussed earlier, there are two type of ions. One are the positive one, other one are the negative one. So how do they form? When the electron is lost, it's a positive ion, which is cation, and when electron is gained, it's a negative ion, anion. What are the cations? Cations are the one which carry positive charge. The example is sodium. What is the ideal condition for sodium to give off this one electron? So the inner shell would be complete. Now look over here, it has 8 electrons. This is the ideal condition. So uh, cation are formed by the loss of electron. But keep in mind that this is an endothermic process. Now, how do we define endothermic process? You might have learned it earlier. If not, I'm going to explain it. Endothermic means endo mean inside. The heat is taken in, the energy is taken in. Why? Because the electron has to be removed. So much energy is required to remove that electron. What are anions? Anions are the one which carry the negative charge, and chlorine is the one with 7 electrons in the outermost shell. It is going to accept 1 electron. Now the ideal condition would be a complete outermost shell which has 8 electrons, but it's an exothermic process because you are adding in an extra electron. Definitely there is a repulsion, and when there is a repulsion, it means there is production of heat. So energy is given off. So cations are more abundant. They are more positive ions as compared to the negative one. If you look at the periodic table, you can easily get a picture. Now all the metals that are the d orbital one that are present in the middle of the periodic table, these all are positive one. So mostly elements in the periodic table are metals. So most of them are positive ones, make positive ions. So it is important to remember that formation of ions from molecule give important information about their structure. Like if we talk about the number of bonds, we can easily get an idea of how many electrons are present or how many electrons are gained or lost or shared. Now, the relative atomic mass. As we discussed earlier, what is the relative atomic mass? That we cannot have proper or a very or a one significant value of an atom, because atom is quite smaller in size, so we just compare one atom with the other one. And in this case we have taken carbon as a standard one because carbon is the most abundant one. It's present in most of the organisms. So scientists took this idea, okay, we'll take carbon as a standard and we are going to compare, we are going to compare other atoms with it. If something is heavier than carbon, so on the basis of how much it's heavy, we'll given that mass. If it's lighter, on the basis of how much is lighter than carbon, we'll given them a mass. So in this way, they just determine the atomic masses. So atom is very small, so definitely the mass is also very small, and it is used to measure the atomic mass, and the unit is atomic mass unit, AMU, which is equal to 1.6s1 into 10 to the power minus 27 kg. So these are the relative atomic masses as compared to carbon 12. Hydrogen is 1.008, oxygen is 15.9994. Now if it means oxygen is much heavier as compared to carbon, that's why its mass is higher than carbon. Similarly, copper, it has 63.546, the mass is higher. It's heavier than carbon, it has more number of shells, it has more number of electrons and protons, that's why the mass is higher. So before discussing this one, let's move to the atomic. So this is all about the atom. What is atomic mass or atomic number, or how can we determine the size of an atom. But in the very next video, we are going to discuss the isotopes, the other topics. So for other topics, you need to watch the our other videos. Thank you very much.